Okay, in the last episode we talked about congruency, and we said the informal definition of congruency is that two shapes are the same size and the same shape. Then we went into more detail when it came to triangles. We said that for triangles, the formal definition of congruency is that you need to have 3 pairs of corresponding angles that are congruent and 3 pairs of corresponding sides that are congruent. And if you have those 6 things, right, there are 6 pieces of information here. If you have those 6 pieces of information, you know that the triangles are congruent. And conversely, you know that if the triangles are congruent, they have all 6 of these facts here. These 6 pieces of information are correct. 3 pairs of corresponding angles are congruent, and 3 pairs of corresponding sides are congruent. And we talked about what that really looks like. Looking over here, let's get that better in frame. I think we've talked about this before. If I want to show that 2 segments are congruent, I put a little hash mark here and a little hash mark on the other that is congruent. So anything that has one hash mark like that is congruent to these 2. And then if you have something else, another pair that's congruent to each other but not to the first pair, you put 2 little hash marks. For the third one, you put 3 little hash marks. That's what that is. And the same thing's true of the angles. You put these little curves in here, these little arcs. 1 means these 2 are congruent. 2 means these 2 are congruent. And 3 means these 2 are congruent. So here is a situation where we have congruent triangles by definition because we have 3 pairs of corresponding sides that are congruent and 3 pairs of corresponding angles that are congruent. And the way you write that is with a congruency statement that says triangle ABC is congruent to triangle XYZ. This is what a congruency statement looks like. And specifically what this one says is that angle A is congruent to angle X. And it says that because the A and the X are in the same place. They're both first. And if we look over here, we see A has the 3, X has the 3. A and X are congruent. Angles A and X are congruent. Angle B is congruent to angle Y. That's true as well here and here. And you can see that, where are we here? B and Y are in the same relative position of the congruency statement. They're in the center of their 2 respective triangles, the way they're written. And C is congruent to Z. They're the third one here. They're the third angle here. And they are congruent as well. The other 3 pieces of information that are contained in here is that side AB is congruent to side XY because they are the first 2 letters here and here. Looking over here, side AB has the 1 hash mark. Side XY has 1 hash mark as well. And that's what this says. Okay. We also know that BC is congruent to YZ, which we write like that. And we see it on here because BC and YZ both have the 2 hash marks on it. So in order for it to be a valid congruency statement, it needs to reflect what is true about the triangles in terms of the angles and in terms of the sides. We've got one more side. We've got AC, right, which is these 2, AC, which means AC has to be congruent with XZ, which is right here, and it is. These 6 pieces of information together say that we have 2 congruent triangles. Now, here's the fun part of this, if there is a fun part of this, and that is we don't want to have to look for all 6 pieces of information every time. You got to figure that at some point, after you've got some number of pieces of information, you have as much as you need to know. And that's what we talked about. We talked about the shortcuts. And what we said was that one of the shortcuts is that if you have three side lengths, three pairs of side lengths that are congruent, this one and this one, this one and this one, this one and this one, you don't need to look at the angles at all. Those two triangles have to be congruent. And the way I demonstrated that to you was I said, look, if you had this line and this, or this segment and this segment and this segment, and you needed to make a triangle out of them, there's only one triangle that will work. There's only one triangle you can make with lengths of those sizes. And it will look like this. I mean, it may be rotated, or it may be translated, or it may be reflected. Any kind of transformation could happen to it. But they are congruent. So you have no need to worry about angles if three pairs of corresponding sides are congruent, because if three pairs of corresponding sides are congruent, the triangles are congruent. And here's how you write that. DF is congruent to QS, right here. FE is congruent to SR, here and here. And DE is congruent to QR, here and here. You need these three pieces of information in your proof. If you're going to do a proof, you need to show that these three things are true. And once you do, you can say that these two triangles are congruent, and you know it because of side, side, side congruency. And when you're writing a proof, sometimes these pieces of information are given. They're marked on a drawing, or they're given in words. So it doesn't take very much to put that in, but it has to be in your proof. You have to be able to check off three congruent pairs of sides in order to have side, side, side congruency. Let's give an example of what that looks like. Let's see, bring this over here. Okay, and here's the situation. It says that this segment right here is congruent to this segment. This segment here is congruent to this segment. That's how they're marked. One hash mark here, two hash marks here. So you have two pairs of sides that are marked as congruent. And that's all you have. So you might look at this and say, well, I just have two pairs of sides. I don't have a third pair of sides, except for one thing. These two triangles share a side. This side, this segment right here, is a side of this triangle, and it's a side of this triangle. And when that's true, since it's the same segment, it has to be congruent to itself. That's called the reflexive property. Everything is congruent to itself. So this segment is congruent to itself, and so it acts as the third pair of sides. And so this particular pair of triangles is congruent because of side, side, side congruency. Okay. So another shortcut that we went over in the last episode, the last meeting, or the last video, looked like this. Let's zoom this back out. Not quite so much. There we go. And what we said was, if you have, there we go, if you have two pairs of congruent sides, here and here, and here and here, right? Not three, but just two. And the angle created by those two sides, here and here, are also congruent. That's enough to show that the two triangles are congruent. So in words, if two pairs of corresponding sides are congruent and the angles created by those sides are congruent, it's important that the angle you're talking about is the one that's created by those sides right here. It has to be that one. If you have that situation, This is how it would be written out. ln is congruent to gi, right here and right here. mn is congruent to hi, that would be right here and right here. And angle n is congruent to angle I, that would be here and here. When you have those three things in your proof, if those three things are true about these two triangles, you can stop. You don't have to look at the other two angles. You don't have to look at the other side. You're done. These two triangles are congruent, and it's called side angle side congruency because you have side angle side congruent to side angle side. The angle has to be between the two sides, and if it's not, then the triangles aren't congruent. What does that look like? Well, it says if two side pairs and one angle pair are all congruent, but the angles are not created by the congruent sides, the two triangles are not congruent. In other words, this works side angle side, but if the angle is not between the two sides, either angle side side, or if you see it the other way, side side angle, you do not have congruent triangles. Let me show you why. Okay, here I have this situation that I've drawn where this length is not decided, but this angle is. I know what this angle is. I know what this side length is. I don't know this angle, but I know this side length. So I have angle side side. Okay? Here is the thing. And it looks like, well, how could I have any other triangle but this? But if this is on a hinge, because I don't know this angle and this can swing back and forth, here's how the end of it here is going to swing. It'll go outside here and then come back inside over here, right, in a circle. If it does that, then it's crossing here again. What does that mean? That means that I have a triangle that looks like this, here and here and here. And it's clearly not the same shape as the orange triangle. But it has the same angle here. It has the same side length here. And it has the same side length here because this and this are congruent to each other. So even though I have angle side side, that's not sufficient to show that the two triangles are congruent. Okay? That's why angle side side doesn't work. So let's take a look at a couple of these to see what we've got. Right? We have two shortcuts already, and here's what we have. Here's a drawing. Do we have side angle side here? Well, the first thing you want to look for is, do I have all 6 sides? Because that makes it easy. And the truth is you don't. You've got these two are congruent, these two are congruent, and these two we don't know. They're not marked. And there's no way to find out from this drawing. So we don't have side, side, side. And so far, the only other shortcut we have is side angle side. It's got to be the angle that's created by these two sides here and the angle created by these two sides here. If they are congruent, then the two triangles are congruent by side angle side. And we know, even though they're not marked, we know that these two angles have to be congruent. How do we know that? They are vertical angles. So we can use that fact that vertical angles are always congruent to show that these two angles are congruent and side angle side congruency is going on here, right? That's what we have. Let's look at number 7 here for a minute. These two triangles are not congruent, even though they have an angle pair that is congruent, a side pair that is congruent, and another angle another side pair that's congruent. And this isn't ASS and this isn't SAS. This is actually nothing at all. Take a look. This triangle here has two side lengths that are congruent to these two, and the angle between them that's congruent to this angle over here. That's nice. And if over here I had these two sides and the angle between them congruent as well, that'd be great. In other words, if I had this side congruent to this side, and this side congruent to this side, which I have, if this angle were congruent to this angle, that would be side angle side. But I don't have that. I have this angle over here and this angle over here. This one's between the two sides, this one is not. So those two are not congruent triangles. Let's take a look at one other, as long as we're at it. We look at this and we say, do we have three pairs of congruent sides? And we look at this, we say, well, no, I don't know anything about the side lengths, not here and not here. I know that all the angles are congruent, but I don't have any shortcut that works that way. And we'll go over that in a minute and we'll see. But based on what we know so far, we don't have any side lengths, so it can't be SSS and it can't be SAS. So let's look for a minute at angle, angle, angle and decide whether or not that can be a shortcut. And the truth is it can't. So why not? Well, here's why not. If you look at these two triangles, the ones that are embedded in each other right here, they have the same angles. They are the same shape, but they are not the same size. So just having two angles or three angles is not enough. And let me tell you why I'm mentioning the two angle thing. If you know that two angles, two pairs of angles of two triangles are congruent to each other, you know for a fact the third one has to be. The third pair has to be congruent. And why? Well, think about this. They have to add up to 180 degrees, the angles of a triangle. If I add this and this, whatever that number turns out to be, I subtract it from 180, and that's the measure of this angle. If I'm going over here, I'm doing it again with exactly the same numbers. I'm adding the same two numbers together, subtracting it from 180, which is exactly what I did here. The answer has to be the same the second time too, because I'm doing exactly the same arithmetic. And that means these two angles have the same measure as well. So it is a fact that if two angle pairs of two triangles are congruent, the third angle pair has to also be congruent. Okay. Now, here's something kind of interesting. If I have two triangles like this, right, and let's just say I haven't written this in yet. Okay, you can tell this is the second attempt at this video because I got some stuff written on here already. But let's just take a look. If you look at these two triangles, they do not look originally, or just at first glance, as if they have the same angle measurements. Sure, you got a 50 degree here and a 50 degree here, but the second one's 85 here, the second one is 45 over here. But for both triangles, they have to add up to 180 degrees. So let's look what happens. 45 and 50 is 95 degrees. Subtract that from 180, and you wind up with 85 degrees over here. Okay. Here I've got 85 and 50. If I add them together, I have 130. Subtract that, 135 rather, subtract that from 180, and I get 45. And lo and behold, all three angles here are congruent to their corresponding angles over here. It doesn't mean the triangles are congruent, but it is something you need to recognize, that just because at first glance they don't look like they're congruent angles, they may still be. Okay, so now what happens if I have a pair of angles where I've got, let's let's see, what have I got? I've got two angles that are congruent. Let's say these two and these two, which means that the third one is too. And I know that one side of each triangle is congruent to the other side. Okay, here and here. Well, going back up here for a minute, what do I know? Well, I know these two triangles are the same shape but different sizes, or at least they appear to be. But if I found out that this side here is the same as this side here, it would mean they are the same size. The angles would tell me they're the same shape, and just one of the sides being the same, and again, it has to be the side between the same two angles, the corresponding angles, right? The 1 and the 3 here, and the 1 and the 3 over here. But if those are congruent, and they are corresponding sides, that's enough to tell that the two triangles are congruent. So how does that work out? It works out like this. And notice, it doesn't really matter which side you pick, right? So let's say over here, I say that this side here is congruent to, to this side over here, okay? Right? This side is congruent to this side. That's the side between the two angles. But that's enough to tell me, since I know that the triangles are the same shape because they have the same angle measurements, knowing that just one pair of sides is congruent tells me the two triangles are the same size. And the same thing would be true if I used this one over here and said this one that's not between the two angles and this one that's not between the two angles are congruent to each other. It still tells me the two triangles are the same size. So that means angle, angle, side, and angle, side, angle are both valid shortcuts. It's important that you write it in the right order. In this case, angle, angle, side would be angle, angle, side here, right? Angle, angle, side, congruent to angle, angle, side. Okay. And angle, side, angle would go the other way. Angle, side, angle, angle, side, angle. And the letters tell it as well. Is the side between the two angles? Not here, but yes, here. So that's how you write the reason that you know, the shortcut that you know, that you used to find out that the two triangles are congruent. In words, it's if two angle pairs and one side pair are congruent, the triangles are congruent. So let's take a look at another example. I know that this side is congruent to this side. But they're the only two sides I have, so I can't do side, side, side. And I can't do side, angle, side, because I still only have one pair of congruent sides. But I do have an angle here that's marked as congruent to this angle over here. In this case, the fact that they're 90-degree angles doesn't really matter. It's just important that they're congruent. So I need another pair of angles. And of course, we just saw one like this a moment ago. We know that these are vertical angles, so they have to be congruent. And now what do we have? Angle, angle, side, or angle, side, angle? Let's take a look. Here I've got an angle that's congruent to that angle. I have an angle again that's congruent to another angle. And then I have the side. So it's angle, angle, side, or angle, angle, side. And it doesn't matter whether you write it angle, angle, side, or if you happen to see it backwards or the other way. I don't know which one's backwards. They both work. The one that's not going to work here is this one. Okay, they don't work. That one doesn't work because it's not what you have. You don't have a side between the two angles. All right, just one more here. Okay, number 5. What do I have? Well, this one's actually clearer. I don't have to really figure anything out. I have a pair of angles that are congruent here, another pair of angles that are congruent here, and the sides between those two angles are congruent. That's pretty much all I need. And this time the side is between the angles, so it's angle, side, angle. Okay? That's the situation here. All right. So now we've done those. There is one more shortcut to show you. And this one has to do with right triangles. And it only works for right triangles. But here's the situation. What if I have two right triangles? And I know they're right triangles, so I know one of the angles. I know this angle is congruent to that angle. But what if I know this side and this side are congruent to this side and this side? Is that enough, right? Two sides and the right angle. Specifically, look at what I'm looking at. I'm looking at one pair of legs and one pair of hypotenuses. Well, how am I going to know that those two are congruent? And I mean, the two triangles. How am I going to know the two triangles are congruent? Well, here's the thing. Pythagorean theorem says that a squared plus b squared, whatever that is, has to equal c squared. Okay? So here it is. A squared plus b squared equals c squared. And on this one, a squared plus whatever this is has to equal c squared. Right? And that looks like that. A squared plus whatever that is squared is equal to c squared. And now, if I have these two equations, right, I have this equal to c squared and I have this equal to c squared, it means these two things have to be equal to each other. Because if two things are equal to the same thing, they're equal to each other. That's called the transitive property. You'll notice I sort of wrote it out like a proof here. So I have a squared plus b squared is equal to a squared plus whatever side that is squared. So now what? Well, I can subtract a squared from both sides. I have b squared is equal to the mystery side. I can take the square root of both sides, which means that b is equal to the mystery side. So then I go back here and I say, well, okay, if this is a, b, and c, this also has to be a, b, and c because this is congruent to this is congruent to this. The remaining sides, here and here, have to be congruent. Okay? So basically what I'm saying here is the square root of both sides. And so s, side, side, side. That's what I've got here, except that I didn't really have those two sides. And besides that, why should I have to go through that rigmarole every time I find two right triangles with legs that are congruent and hypotenuses that are congruent? I mean, I just did it without the numbers. Certainly every time I do it with numbers, it's going to work as well. And it does. So we have another shortcut. If you have two right triangles, and those right triangles have a pair of congruent legs and congruent hypotenuses, the triangles are congruent. Okay? We call that hypotenuse leg congruency. And that pretty much brings you up to date on all of the different kinds of ways you can prove that two triangles are congruent. And in the process, we've covered some vocabulary here. The 5 shortcuts for showing that two triangles are congruent are side, side, side congruency, side, angle, side congruency, an angle, angle, side congruency, angle, side, angle congruency, and hypotenuse leg congruency. So again, side, 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 angle, angle, side, angle, and hypotenuse leg. If I asked you, what are the 5 shortcuts for showing that two triangles are congruent, you should be able to rattle these off to me. Or if I ask you, how can you tell if two triangles are congruent? The answer to that question would be this, 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 or this. And that's it. That's triangle congruency. Now it's just a matter of practicing and learning how to put what you learn into proof form. And we'll get to that next.